Right, I want you to show you where the formula comes from for the binomial expansion work we're going to be doing. If this doesn't work, I'll show you in lesson as well. So I thought it might be nice in this, but if not, I'll like this, but if not, I'll show you in lesson. So this is the stuff we did as sort of part of first year maths. So 2 minus x cubed, we said binomial coefficients are 1, 3, 3, 1. And to start with, we just looked at those as coming from Pascal's triangle. And then we took first part to the highest power and took the power down by 1. Second part to the lowest power and up by 1. And then we said you multiply across. So the other thing, before I do that, is we said you can work these out. Instead of using Pascal's triangle, this is 3, choose 0. So that matches the power of the second part. 3, choose 1. 3, choose 2. 3, choose 3. Putting all that together, you get 2 minus x cubed is equal to 3, choose 0 times 2 cubed times minus x to 0. And then I'm just going across the rows. So I'm trying to write quickly because of my phone memory. Right, minus x squared. And then 3, choose 3 times 2 to the power 0, lots of minus x cubed. So that takes us to there. There's a general formula for this. So I tend to teach this more as a pattern, but in your formula book you have this formula, which is a plus b to the power n is equal to a to the n plus, rather than writing n choose 1 like that, it's written like that, but it means the same thing. And then the power of a comes down by 1, power of b up by 1. Like so. And then you get a general form plus b to the power n. If we substitute in, instead of having a plus b, if we substitute in 1 plus x to the power n, this is kind of the direction we're heading in. The other thing I meant to say is restrictions. So for this formula here, the only restriction is on this power, and n has to be a positive integer, so it's a member of the set of natural numbers, so positive integers. So that's the only restriction. You can put anything you want in here and here, no problem. So all I'm doing now is I'm replacing a with 1. 1 to any power is 1. And so this becomes b is x and then plus x to the power n. So that's 1 plus x to the n. N is still a natural number at the moment. That will change. Going on to the next one, I just need to look at these coefficients here, the binomial ones, and we're going to think about a different way of writing them. So n choose r, we did this, is n factorial over r factorial n minus r factorial. So it follows that n choose 1 is n factorial over 1 factorial n minus 1 factorial, and this, the top, is equal to n times n minus 1 factorial over n minus 1 factorial. They cancel off and they leave you with n. Second one, n choose 2, n factorial over 2 factorial, n minus 2 factorial. The top of this is n times n minus 1 times n minus 2 factorial over 2 factorial n minus 2 factorial. So they cancel off and that leaves you with n minus 1 over 2 factorial. And that pattern just continues. So you could work this out, but n choose 3 is equal to n minus 1, n minus 2 over 3 factorial. So you have to take an extra one off to cancel it down, and so on. So it follows that 1 plus x to the power n is equal to 1. So I'm just replacing the n choose 1 in the formula I had on the other board. And then all the way up to x to the power n. We've still at the moment got this restriction on n. So we've kind of said, okay, n is a positive integer. We want to lift that restriction on n. So ideally we want n to be any real number. So we can start raising things to any power. In order to do that, we need this series to converge, because if it just gets bigger and bigger and bigger, it's just totally meaningless and unmathematical. So if n is a positive integer, you'll keep taking 1 off of n until you reach 0 and it will terminate. If n isn't a positive integer, then you have an infinite series if I take off this end term. So I just want these powers of x to get bigger and bigger and bigger. So that's our pattern. We've now got an infinite series. In order for this to converge, we need each term to approach 0 as you go through the series, so that you're adding on a smaller and smaller and smaller amount. And in order for that to be the case, we need whatever you're putting in, which is your x value, to be between -1 and 1, so that when you raise x to a bigger and bigger power, you get something that's closer and closer and closer to 0. And so by lifting this restriction on n and saying n is going to be any real number, we have to put a restriction on x. So this is valid for -1 less than x less than 1. So we need x to be sandwiched between -1 and 1. So when you raise it to a high power, you get something that's close to 0. Another way of writing this is that the modulus of x is less than 1. That means that the positive value of x is less than 1. They mean exactly the same thing. So that's where the formula comes from. You don't need to know that, you just need to know how to use it. So any questions further on that, just let me know. You're welcome just to kind of watch this video, don't feel like you need to take notes, and then move on to some actual examples of how to use it. I hope that was clear.